Good morning, everybody. So we are starting with officially the second lecture in root locus. Yesterday, I had shown you root locus for a system which was in denominator having two poles. One pole was at origin, another pole was at -4. So yesterday's numerical we had taken GSHS was k divided by s into s plus 4. Exactly the same kind of numerical we are taking, but instead of s is equal to 0, we are taking one pole today at s is equal to -1. So this numerical we will see, and we will see it by the standard root locus method. So yesterday we see exactly what we are doing. So GSHS equal to k divided by s plus 1 s plus 2 it was given. We had first found 1 plus GSHS, and that had given us an equation of a square plus 4s plus k is equal to 0. And there we had been changing the value of k from 0 to infinity. We found that if we are substituting the value of k from 0 to 0 and a little bit more, so initially when k was equal to 0, there were two poles. One was at 0, another was at -4. So these were the two poles. It's a two pole system because characteristic equation is s square plus 4s plus k. So I'm just giving you a recap of what we had done yesterday. So GSHS was k divided by s into s plus 4. K is the system gain. What is root locus? Root locus is as we are increasing the value of k from 0 to infinity, how these two poles are going to change its position. So these two poles initially at k is equal to 0, they are at s is equal to 0 and s is equal to -4. But they will not remain there forever. As we are going to increase the value of k from 0 to infinity, we will find that the position of all these poles are changing. So k is equal to 0 will keep on shifting leftward as we are increasing the value of k. K is equal to -4 pole, they will keep on shifting rightward as we are increasing the value of k. And we had found that at k is equal to exactly the value of 4. So when the gain was 4, both these two poles actually they were hitting each other exactly at s is equal to -2. So we are actually checking what is the position of pole at a real axis on the left hand side of S plane with the increasing value of k. So at k is equal to 0, poles were at 0 and -4. We are increasing the value of k. At k is equal to 4, that is gain is equal to 4. Both the poles were hitting each other at -2. That point was called as breakaway point. At this point, the value of zeta was equal to 1, and this is the point where we are getting the critically damped response. So breakaway point is a point where we are getting both poles are real poles, and this is the value of k where we are getting damping as critical. If you are increasing the value of k further, we will see that poles are not remaining on the real axis, they are jumping on geometric axis. And then we are increasing the value of k up to infinity, we are finding that the poles are exactly getting shifted on a real value of -2 and they were getting upward. That means plus minus j2 plus minus j3 plus minus j4, and they were going towards infinity, but they were increasing parallelly with respect to the geometric axis. So if this was geometric axis, the poles were going in upward direction like this, poles were coming downward direction. And finally we found the root locus. The root locus line whichever was root locus for the pole which was at 0 initially, that is origin, it was going to -2 and then going upward. Pole whichever was at -4, it was coming to -2 and going exactly downward. So what is the locus of the root? Locus means path. So locus of the root is like this, they were coming and they were going like this, and this line was exactly parallel with respect to geometric axis. What was the conclusion? Conclusion was from k is equal to 0 to k is equal to infinity, we found that initially the poles were coming towards the negative of S plane at -2 and then they were exactly parallel and going towards infinity. Never we found that the root locus path is crossing the j omega line and coming to the right hand side of S plane. So the poles were actually parallel to the j omega axis in the left hand side of S plane, hence the poles were always stable, because left hand side of S plane means poles are always negative or having the negative real part, and they are always lying in the negative side of S plane, and poles are always stable. So this is a system which was given by GSHS k divided by S into S plus 4. Same as here in this numerical you find k divided by s plus 1 into s plus 2. Here also you will find that at k is equal to 0, initially the pole will be at minus 1 and minus 2. As you are increasing the value of k, they will come and collide at minus 1.5, and from there they will go upward and downward exactly parallel with respect to j omega axis. So yesterday's numerical also was absolutely stable. What is the definition of absolutely stable? From root locus GSHS, any value of k greater than 0 to infinity, we will be finding that root locus is never leaving the negative side of S plane. Root locus is always confined in the left hand side of S plane. So hence k divided by s into s plus 4 or k divided by s plus 1 s plus 2, the system here, all are going to be actually absolutely stable system. What is the definition of absolutely stable? GSHS we are talking about. GSHS is OLTF. So what is root locus? Root locus is GSHS will be given to us, k divided by s plus 4, s12, whatever something will be given. Whether it's a two-pole system or three-pole system or four-pole system in GSHS, that is open loop transfer function. From there, we are actually estimating what is going to be the stability of closed loop transfer function. What is the closed loop transfer function characteristic equation? It is 1 plus GSHS. So given as GSHS, from there we are estimating what is going to be the stability of closed loop transfer function characteristic equation. So that's why we are finding first 1 plus GSHS. In this case also, if we are finding 1 plus GSHS, we will find that it is s square plus 3s plus 2 plus k, something like that it will be. And from there we will be doing it, and we will be finding out that for every value of k from 0 to infinity, root locus will be confined in the left hand side of S plane. But we are not going to do it the way we did it yesterday. Today we are going to do it with the root locus method. So what is the root locus method? There are some 8 or 9 steps. So all those steps I will show you later on. But let me do the steps initially. Before telling you formally what are the steps, I will do the numerical, solve the numerical, and initially you will not understand few things. It is agreed, no problem. Nobody understands root locus in the first go, because it is a step. So what is actually we are doing, that I told you yesterday, that I have shown you. In that method also you can plot this root locus. What you do is first 1 plus GSHS, that means s square plus 3s plus 2 plus k, and in that case you have to find the two values of s1 and s2, that is what are the pole positions. So we'll be finding two equations of s1 and s2, and there you keep on substituting the value of k from 0 to infinity. You will be finding the value of s1 and s2, keep on plotting them, and whenever you're plotting them, actually you will be seeing that all the roots are lying in the left hand side of S plane. Initial roots are at -1, -2. At one value, they will collide at -1.5, and then they will go in the 1. So -1 pole will go in the upward direction, and -2 pole will come in the left hand direction. And finally, you have to say that the root locus plot is parallel to j omega axis, and system is absolutely stable. So we are doing this thing to find the stability criterion, whether the system is absolutely stable or relatively stable. What is relatively stable? If you are finding the root locus plot for three poles, okay, so I will show you just for showing sake, I will show you the root locus plot for just 1 minute. I will show you the root locus plot for, okay, is it visible? Are you are able to view this root locus plot? So a new diagram I have shown.
Yes, sir.
Anybody please respond. Okay, so this is the root locus plot for pole, a numerical, that is, I will show the numerical first. So what is the numerical? GSHS will be given. GSHS given as now, GSHS given now, k divided by s into s plus 3 into s plus 6. That means if your open loop transfer function is k divided by s into s plus 3 into s plus 6. That means what are the open loop poles? One pole is at k is equal to 0. Sorry, at k is equal to 0, you are going to find three open loop poles. S is equal to 0, s is equal to -3, and s is equal to -6. So ये याद रखो थोड़ा, because very briefly I will explain you the root locus plot for three open loop transfer function poles. So open loop transfer function poles are s is equal to 0, s is equal to -3, and s is equal to -6. The same way we have done numerical yesterday, you can solve this numerical also. So what you have to do first, find characteristic equation. What is characteristic equation? 1 plus GSHS. That means what is that? s cube plus sorry s into s plus 3 into s plus 6 मल्टीप्लाई करो उसको जो भी होता है, okay, plus k. Okay, so there that will be a equation s cube plus something of s square plus something of s plus k, and there you have to just keep on substituting the value of k is equal to 0 to infinity. You will be finding how the roots are changing its position. Okay, so initially you can see, so इतने सारे देख के घबरा नहीं जाना, because this is very easy. You will be able to do all these things. So initially you just find what's happening. Initially one root is at s is equal to -6. Initially one root is at s is equal to -3. Initially one root is at s is equal to 0. That means when k is equal to 0, I am finding that there are positioning of three poles. One is at s is equal to 0, another is at s is equal to -3, and there is no root locus between -3 to -6. So between 0 and -2 root locus is there, but between -3 to -6 root locus is not there. ये कैसे समझेगा? बहुत ही आसान है, I will tell you. But again, root locus is there from -6 towards -infinity. So this is the locus of one root. Okay, so whichever root is there at -6 at k is equal to 0, that if you are increasing the value of k, this root will keep on going deep into geometric axis. That is -6, -7, -8, it will go towards. So when k is equal to infinity, position of this root which is there at -6 at k is equal to 0, that root will go to -infinity. वो जाता ही है. This is a characteristic of the system. Now there are two other roots. So this is a absolutely stable pole. So there are three poles. One is at -3, one is at 0, another is at -6. So this -6 at k is equal to 0. That means when gain is equal to 0, this is at uh, s is equal to -6. And as you keep on increasing the gain, this root will keep on becoming more and more and more and more stable. So it will go deep into geometric axis. So this is an absolutely stable pole. For two pole system, we found that both poles are absolutely stable, because yesterday's numerical, one root was changing its position from 0 to -2, and from -2 it was going up. That means -2 plus minus j omega. It was going like that. So, but every time they were in the left hand side. This -6 root is also like that. It is always confined in the left hand side of S plane, and as k is increasing, this root is becoming more and more and more and more stable. So this is absolutely stable root, no problem. But check these two roots. Root locus is about path of the root, or loci or loci as you call it. Loci means the location, the path of the roots as we are increasing the value of the gain k. So initially there are two roots. So I told you the GSHS, the value is k divided by s into s plus 3 into s plus 6. So वो steps वेब ज़्यादा important बात नहीं है, वो steps सबको करना आता है, it's very easy. But to understand what is root locus, what is exactly happening in the system, that's what I am giving too much time in initial step, because एक बार step बता दिया तुम लोग ये सब देखोगे नहीं, फटाफट फटाफट within 10 minutes you will be able to solve the numerical. But exactly होता क्या है, that I am telling you like a story. So initially ये -6 का problem solve हो गया, because this initially at k is equal to 0, this pole will be at -6. As I am increasing the gain, it will keep on going in the negative side of S plane. So it will keep on getting stable and stable, absolutely stable pole. There are two poles which are conditionally stable pole, or they are relatively stable pole, we call it. What are the poles? Whichever is at 0 and -3 at k is equal to 0. What will happen is, whenever you are increasing whenever initially you are keeping the value of k is equal to 0, this pole will be at 0 and this pole will be at -3. Now you are increasing the gain k. What you will find is the poles, these two poles are keep on coming closer to each other. That means whichever pole was there at 0, it will keep on coming towards this point. So what is this point? Breakaway point. This breakaway point will be able to calculate. This is the most important part, step number 4. Student अटक जाते हैं, बहुत easy steps है. Every step is similar for all the numericals. Okay, only you should be able to solve second order, third order system equation, and which is solvable in calculator. And we will give you a numerical where it is solvable at s cube only. So we will not ask you s to 4, because we know s to 4 solving is not easy in exam. Okay, so we'll be asking you up to x to 3 only. So if you solve that, you are finding that these 2 points, s is equal to 0 and s is equal to -3, as you keep on, so this is at k is equal to 0 value, at 0 and -3. Now you are increasing the value of k. Okay, वो -6 वाला उधर जाएगा, वो छोड़ दो, भूल जाओ. So 0 and -3, as you are increasing the value of k, they will keep on coming closer to each other. You can check in this 1 plus GSHS equation, you can keep the value of k is equal to little bit more, so 0 0.3, 0 0.5, 0 0.61, likewise. You'll be finding that these two poles are coming closer, closer, closer to each other. Then for a certain value of k, you will find both the poles are at minus 1.27. In that case, this pole minus 6 also will not be at minus 6. It will shift it, maybe somewhere at minus 8 or minus 10 for a certain value of increased k. Okay, so for a certain value of increased k, all the poles are always changing its position in a certain direction for increasing value of k. For a certain value of k, these two poles will come and collide at each other. At that point, zeta is equal to 1. Zeta is equal to 1 is critical damping. This is the highest gain for which we are getting non-oscillatory response, because the poles are still on real axis. The poles are still on real axis and the position of both the poles are same. Now I increase the gain further, you will be finding that this pole 0 it is shifted upward, and accordingly this pole minus 3 it will be shifted downward. So if it comes to minus 1.27 plus j, then the below will be minus 1.27 minus j. Further you increase the value of k, you will be finding that poles are here. Further you increase the value of k, poles are here, but still you are finding that poles are in the negative side of S plane. That means for whichever gain you are finding the poles are at minus 1.27, that is the highest gain at which you are finding non-oscillatory response. After that, if you are increasing the value of k, you will be finding that the poles are coming like this. जब तक वो real axis पे है, its response will be non-oscillatory. As soon as you are increasing the value of k further, what we find is when k is equal to 0, at that time system is having damping highest. You can calculate it. As you are increasing the value of k, the damping is reducing. Damping is reducing means system is becoming faster. System gain is increasing. System gain is increasing means system is becoming more and more unstable. Okay, it is still not unstable, but stability is reducing. Unstable is a different thing. Unstable means poles are in the right hand side. All these parts in the left hand side of the root locus, you are finding poles are still in the left hand side of S plane. System is stable, overall system is stable, but stability is reducing. So relatively, it is becoming less and less stable. That is very important. So initially it was 0 and minus 3. You are increasing the value of k at one value for a certain value of k. वो कौन सा है? We can calculate it. You are finding the pole position is minus 1.27. This is called breakaway point. Why break away? Because further you are increasing the value of k, the poles are going to go in the imaginary axis. Still you don't stop, you keep on increasing the value of k, you are increasing the value of k, poles are jumping, but just check that is slowly coming towards the j omega axis. That means it is going slowly to the imaginary axis. Likewise, if you are increasing for a certain value of omega, for a certain value of omega, or for a certain value of gain k, what is that value? 162. This we can calculate. Okay, so till 0 to 161.99 in the equation, above equation, what is the equation? 1 plus GSHS. What is GSHS? K divided by S into S plus 3 into S plus 6. So उसका numerator ले लो, उसका numerator जो है, that is the characteristic equation. That means S into S plus 3 into S plus 6, all this multiplication plus K is equal to 0. In that equation, if you are substituting K value till 161.99, then you will be finding that all the poles are having a negative real part. That means one pole will be minus 6, minus 7, minus 8, minus 9, we keep on going there. Another part, which is a complex conjugate pole, you will be finding that its real part is still negative. Whenever it is k is equal to 162, you will be finding that the real part is 0. Imaginary part is there. Imaginary part is plus minus 4.24j. How do I know so much thing? It is given here. You can check here. That is omega marginal is 4.24 radian per second. So we know that S is equal to sigma plus j omega. In this case, it is minus sigma plus j omega. So at 162, that sigma becomes 0. That means pole is on j omega axis. And at which point on j omega axis? It is plus minus j 4.24 radian per second. So ये दो जो चीज है, k marginal and omega marginal, this you can find out from the characteristic equation by using Routh-Hurwitz criteria. So this is where the Routh-Hurwitz criteria is falling into place in case of coming into use in case of root locus. That's why हम लोग पहले Routh-Hurwitz criteria कराते हैं, बाद में हम लोग root locus कराते हैं. Because in root locus, last step is to find what is the frequency at which you are going to get k marginal. And what is k marginal? At that gain, the root locus is thinking of jumping towards the right side of the j omega axis or right side of S plane. Okay, So at k marginal, that means if you're substituting k is equal to 162, you'll be finding that both the poles are on j omega axis. In that case, if you are increasing the value of k further 162 plus, you will be finding that ये थोड़ा सा घुसा है देखो right side में. So the poles are slowly entering the right hand side of j omega axis, and further you increase the value of k, you'll be finding that this thing is going straight towards infinity. Okay, so the pole position will go straight towards infinity. Where is this pole going? -6. It is going towards minus infinity. That is sigma is equal to minus infinity. Where are this poles going? So this pole started from 0, then it had come to minus 1.27, then it is going, still it is negative, then at k is equal to 162 it is crossing the j omega axis, and further if you are increasing the value of k, it will go straight towards infinity, amplitude infinity. Obviously there will be real part, imaginary part, both, and this is a guideline. Okay, this is a guideline. ये guideline हो सकता है. So for three pole system, it is a three pole system. Why three pole system? Because GSH has given us k divided by s into s plus 3 into s plus 6. So open loop transfer function is having three pole. In that case, we will be finding this is called asymptotes. Okay, this is called asymptote. What is the asymptote angle? Very easily we can calculate. So for all three pole system, for all two pole system, asymptote angle will be plus 90 degree minus 90 degree. Yesterday's numerical we had seen it was a two pole system, and the root locus was like this. It was coming like this, and then they are going up. What is that? What is the asymptote? Asymptotes are the guidelines which will be followed by the root locus. So in yesterday's numerical, both the root locus was like this, straight. One was going straight, it was plus 90. Another was going negative, it was minus 90. Minus 90 is actually 270 degree. So if you are finding for a two pole system, there will be two asymptotes. Three pole system, three asymptotes. Four pole system, four asymptotes. So number of open loop pole is equal to number of asymptotes. That means that will be the number of root locus. In that case, for pole system there is no zero. Okay, zero wala part बाद में देखेंगे हम लोग. If it's a only pole system, two pole system, there will be two asymptote. One will be plus 90, one will be minus 90. Minus 90 is 270. Three pole system, there will be three asymptotes. Okay, or three angle of asymptote. One will be 60 degree. ये ऐसे draw होता है, and this point is called a centroid. From whichever point the asymptotes are created, that point is called a centroid. So before drawing the root locus, you have to draw three asymptote angles. What is asymptote? Asymptotes are the line which will be followed by the root locus, and they will go. So in infinity, this asymptote line and this root locus, they touch each other. Okay, so this asymptote means two lines which are going parallel or going very close, getting closer, and they will touch each other at sigma is equal to, or frequency is equal to infinity. So this is the asymptotic line, and for any three pole system, there will be three asymptotes. One will be at this one. This is asymptote angle minus 180. This is asymptote angle plus 60. This is asymptote angle. What is that? It is, I think, 360 plus 180. So this is around 300 degree. Okay, so this angle is 300. Okay, so this is plus 60 degree and this is minus 60 degree. So for three pole system, asymptote angles are plus 60, plus 120, and minus 60, or plus 60, 180, and 300. For a two pole system, the asymptote angles are 90 and minus 90, or 90 and 270. For four pole system एकदम ऐसा होगा, exactly crisscross. So there will be four root locus. In this case, there are three root locus. One root locus is going from minus 6 to negative infinity. Another root locus is coming from 0 to minus 1.27. Then it is going like this. It is crossing the j omega axis again is equal to 162. So till 162 it is stable. After k is equal to 162, system is becoming unstable, and it is going. And where will it go? It will touch this line asymptotic angle at s is equal to infinity. So this line, which is called as a centroid line or asymptotic line, this is actually a guiding force for the root locus. So guiding force for root locus means root locus will touch this angle, touch this line at s is equal to infinity. Same here towards the below. So this root locus is generated actually minus 3. As you are increasing the value of k from 0, it will come here at minus 1.27. Then it will flow and it will go towards negative infinity at s is equal to infinity. And this root locus will touch this guideline. So ये guideline root locus नहीं है. Root locus is this dark line. So this root locus will touch this guideline at s is equal to infinity and at infinity angle. So even if you don't want to draw this guidelines, it will do. So, but we should draw this because root locus will be confined within this guideline. So ये अगर guideline है तो root locus इसके अंदर ही रहेगा, इसके बाहर ये cross करके ऐसा नहीं जाएगा. Okay, that is the significance. So these are the things we have to find out technically. These are the things we are supposed to find out by root locus plot. And you are finding that initially when k is equal to 0 until the value of k when it is coming to the breakaway point, let's say at k is equal to 10, it is coming and touching each other. Let's say, okay, so at breakaway point, let's say the gain is k is equal to 10. That means for k is equal to 0 to 10, the root locus will be real. That means this point will come from here to here, and this point will come from -3 to minus 1.27. So between 0 to k is equal to 10, I'm just taking a value. The root locus is lying on the real axis. If you are increasing the value of k further, these two root locus will be jumping and going in the imaginary direction. Okay, so this is a very important thing. So from 0 to k is equal to 10 or k breakaway point, the root locus is on real axis. That means it is producing non-oscillatory response. As soon as the k is greater than 10, मैंने just एक value लिया, you are finding that root locus is jumping, leaving the real axis and jumping on the j omega axis. As soon as it is jumping on the j omega axis, the response, time domain response will become oscillatory. So oscillatory चलता ही रहेगा, but it will be a decreasing kind of oscillation. Okay, so it is a diminution kind of oscillation because then -2 plus minus 3j, or maybe -1 plus minus 5j, or maybe minus 0.5 plus minus of 7j, you are finding. So oscillation value is increasing, okay, but oscillation is still diminishing as long as the roots are here, and it is always complex conjugate. एक ऊपर रहेगा तो एक नीचे भी रहेगा pole. Okay, so there are three poles. This pole will absolutely stable. This pole will never produce a non-oscillatory response. So if you are seeing the at any value of k, if I ask you what is the total response, combined response, so it's a combined response of 1 exponential and 2. So this 2 will producing a diminishing kind of oscillatory response. Till which value of k? Till 162. And after 162, what will be the response? Or exactly at 162, what will be the response? Exactly at 162, the response will be sustained oscillation. That is, let's say, plus minus 4.24 radian per second. So the position of the pole is here, and the position of the pole is here, these two, and ये अंदर किधर तो रहेगा. So this thing is never going to affect the stability. But these two poles are on j omega axis, means they are going to be having some kind of oscillatory response, a sustained oscillation when they are on j omega axis. So, and after that, if you are increasing the value of k, this poles will enter in the right hand side, and right hand side means it will be a blowing up kind of a response. So it has become unstable now. Now this is how the response looks like. So final summing up, initially this will be here, it will go here, and in this portion the relative stability is decreasing. Whenever the k is 0, at that time this is 0, -3, -6, this is the highest point of stability. As you are increasing the value of k, you are going to find that this -6 is going to get more stable, but because of these two, 0 and -3, because of these two poles, system is going towards the instability. More is the value of k, more is the instability. So k is 90 and k is 100. So k is 90 is more stable because in that case the poles are here. So real value is more negative. K is 100, so k is 90, let's say k is 90, the poles are suppose -1 plus -3j, and k is 110, you will be finding the poles are -0.5 plus -5j. That means as you are increasing the value of k, you are going to find that the poles are shifting towards right. That means that real part of the pole position, they are actually reducing. And real part of pole is reducing means system is becoming more and more unstable because it is shifting towards j omega axis. So this is actually the root locus of three pole system, all the three pole system. Any three pole system you find, this will be the root locus. Okay, any three pole system. There is no zero I am talking about. And any three pole system with real root. So don't catch me there. Any three pole system with real root. What is that? Let's say s plus 1, s plus 7, s plus 19. Okay, the root locus will look like this. Position will be different because breakaway point will shift in the left hand side, then this k will change, this omega marginal will change. But if I say three real roots on left hand side, s plus 1, s plus 7, s plus 90, or you can say s plus 100, s plus 300, s plus 500, every time the shape and look of the root locus will be like this. Only the position of centroid. What is the centroid? From centroid actually you are drawing those three lines which are asymptotes. And if it is three pole system, three real pole system, always the angle of the asymptotes will be 60 degree, 180 degree and 300 degree. But the position centroid from which the centroids are to be drawn, okay, so they will keep on shifting in the left side. If you are taking s plus 100, s plus 200, s plus 300, that means there are three poles which are there at minus 100, minus 200 and minus 300. So in that case you will be finding that this will be minus 100 and minus 200. So for k is equal to 0, you will be finding there are roots placed at minus 100 and minus 200. That means if you are increasing the value of k, in that case they will come and meet exactly at minus 150 or maybe at some other point. It is not exactly the midpoint of two poles. Okay, so it comes to calculation. So between minus 100 and minus 200, somewhere the meeting point will be there. And after, if you are increasing the value of k further, it will shift on German axis. And this minus 300 pole, it will start from minus 300 and keep on going to the negative side. So this is actually the whole story of root locus. So for three real roots, this will be the shape always. So what all things you have to find out? First, you have to find out what are the real axis root locus. Real axis root locus here between 0, minus 3 and minus 6. First real axis root locus will be between 0 and minus 3. Okay, and between minus 3 and minus 6 there is no root locus because minus 3 it is coming to minus 1.27 and coming negative. 0 it is coming to minus 1.27 and going to plus. Okay, so this is the position. So between minus 3 and minus 6 nothing can happen because there is no pole path between minus 3 and minus 6 because this minus 3 is coming to the right and going below. This 0 is going to the left and going up. So there can be nothing in between minus 3 and minus 6. There another root locus will be from minus 6 and it will go to the whole negative axis. So minus 6 to minus infinity will be one path of the root locus. So one locus of the root. What is the second path? 0 to minus 1.27 on real axis and then it will take the imaginary axis path. Okay, that is the roots will become the roots will become plus minus or a plus minus jb or minus a plus minus jb. Another path is from minus 3 it will come to minus 1.27 and it will fall to the. So these are the three paths. Why three paths? Because there are three poles, because there are three roots in the GSHS. One path is this starting from minus 6 minus infinity. Another path is this 0 to minus 1.27 and it will go initially it is stable, relative stability is decreasing at 162, relative stability is lowest, and after that system become unstable. So this is another path. Another path is starting from minus 3 it will come to here minus 1.27 and going below to the negative. So this is the story of how to plot three axis, three pole root locus. Now let us start the process of plotting root locus by the same method. So we are having only 13 minutes time. So jitna bhi time do wo kam hai. So 13 minutes time, very fast we will see what is the root locus of second order system. So what is step 1? Step 1 is first you are supposed to write down how many poles and zeros are there. So we are finding here there is no 0. 0 rahega to pura root locus change ho jayega. We will see that. The same thing we will plot with 1 0. And if you are finding that there is a 0 here, let's say it is s plus 5 or something. So s plus 5, that means 1 0 is there and there are two poles. So if there are only two poles, how many root locus is there? How many root locus you have to draw? 2. That means two paths you have to draw. What will be the path? One will come from minus 1 to some midpoint and will go upward. Another will come from minus 2 and going downward. These are the two paths because there are two poles. One pole will go from minus 1, it will come somewhere in between and go to plus infinity. Another will come from minus 2 to somewhere in between breakaway point and go to minus infinity. These are the two paths. Khatam. But if there is another 0 added here, so I am giving you GSHS with a 0, that means s plus 7, let's say. In that case, there will be only one path because number of root locus, very important, I'm slowly entering that, because number of root locus is equal to number of open loop poles minus number of open loop 0. Okay, so this you will find. I'm repeating again, very important thing. Number of root locus is equal to number of root locus path is equal to number of open loop pole minus number of open loop 0. So in that case, there is no 0. There is only one gain, k. Okay, so there are two poles. So p minus z. P minus z is a very important thing. P is number of open loop poles, z is number of 0, and there is numerical. So I will give you a googly. Numerical will be k into s plus 1 into s plus 3 divided by s plus 2 into s plus 4. So here I will show you two zeros and below I will show you two poles. So there is no root locus path. P minus z is equal to 0. I'll ask you draw root locus. So many kind of Google is possible in this, and it is very sweet kind of a thing. I will show you all the root locus, and biggest thing is we will do on Saturday in one click. So you just define this GSHS and just write a command R locus, and it will draw the root locus for you. जो root locus draw करने में तुमको आधा घंटा लगेगा, MATLAB will draw it in 1 second. Okay, so you will be given s into k into s plus 1 into s plus 3 divided by s plus 2 into s plus 4. So दो pole दो zero, p minus z is equal to 0. I will ask you to find root locus, and you will say sir pole is equal to 0, root locus तो होता ही नहीं है. In that case होता नहीं है, ऐसा नहीं है. In that case one root locus, because why all these three things are going to infinity. Now I am telling you. Generally in control system, the hole and electron concept is already there. So each electron will end in a hole. Okay, exactly the same thing. Whichever gain or whichever root locus plot starts at 0, it will starts at a pole. I'm sorry, 0. It will end at a 0. And where is that 0 kept in this case? The zeros are kept in the infinity. So now I'm going in a different discussion mode. Here, this is root locus is about plot between path of pole to 0. And in this case, it is k divided by s into s plus 3 and s plus 6. There is no 0. There is no 0 means all the zeros are kept in infinity. Okay, so that is a hypothetical thing. So k's or the paths are starting from here 0 and coming here minus 1.27, crossing at 4.24 or crossing at 162 gain, and then if you are increasing the gain, it is going towards infinity. Infinity mein kya hai? Infinity mein there is a 0, and this path is going and ending at infinity. That is the logic. Okay, so in this case, if I'm showing it here like this, if I'm giving you two zeros here, okay, in that case I will show you that one root locus is starting from here and a circular kind of root locus hota hai, it is ending at 1 0. Another root locus is starting from here and your goal jaisa hoke it will enter in another 0. That means no root locus is going to infinity. The difference between this numerical and that numerical where I am putting you two zeros, this numerical you will be finding that only two poles are there. Where are the zeros? Zeros are there at infinity. That's why this pole will start from -1, come in between and will go to the infinity. Infinity means 0. This root locus will start from -2, come at one midpoint and come to negative infinity. Why? Because in negative infinity there is a 0. We have to assume. So here number of pole is equal to 2, number of 0 is equal to 2. So then number of 0 is equal to 0. So root locus path, or rather very correctly saying number of root locus which are going to infinity, number of root locus which are going to infinity will be equal to 2, because p minus z is equal to 2 minus 0 is equal to 2. So this is the simplest numerical. How to find real axis root locus? So first line, poles are at -1 and -2. Second thing, root locus lies between -1 and -2. ये अभी एक important concept मैं बता रहा हूँ, वो सुनो. First you have to draw these poles. So as soon as you write -1 and -2, you have to draw this j omega axis, और सब draw कर करके करना है. Step by step you have to draw. So draw j omega axis, -1 and -2, you draw these two poles. Why have I darkened it? How can I darken it? Or what is the logic behind darkening it? Logic is we have to test whether there is any root locus on this point. What is this point? -0.5. Whether this -0.5 is a part of root locus or not. How can we test that? Uska right side mein dekho. Look at the right side of -0.5. Whether this -0.5 is a part of root locus, or -0.5 is on the root locus or not. Here -1.5 is on the root locus, -1.75 is on the root locus, -1.3 is on the root locus. How can you check that? Any point in between -1 and -2 is on the root locus. How do we test that? Take any point in between -1 and -2. Let's say -1.5. Uska right side mein dekho. Count total number of poles and zeros in the right side of point where you want, where you are asking, is it a part of root locus? So I'll ask you, what is the point? -1.5. -1.5 ka right side mein dekho. How many poles and zeros are there? If the number of poles and zeros are odd, so just check to the right hand side of -1.5. Check to the right. Right means, is there any pole? Yes, there is one pole. Is there any zero? There is no zero. What is the total number of pole and zero to the right side of -1.5? It is 1 plus 0 is equal to 1. 1 is a odd number. So whichever point you are doubtful whether this point is a part of root locus or root locus lies at minus 1.5 or not, उसका right side में total number of poles are 0 if odd, then this point is a part of root locus. I will repeat, check any point, look at its right side, check what is the number of pole, check what is the number of zero. So number of pole and zero is odd. That means this is a part of a root locus. Hence, minus 1.5, minus 1.3, minus 1.1, minus 1.1 is here. Uska right side mein 8 pole. That means minus 1.1 is on root locus. Minus 1.3, right side 8 pole, odd number. That means minus 1.3 is on root locus. Minus 1.5, minus 1.7, minus 1.99. Is it on root locus? Yes, because uska right side mein dekho, right side mein there is only one. One is an odd number. Okay, hence this minus 1.99 also is a part of root locus. Check 2.1. Is 2.1 on root locus or is 2.1 a real root locus point? Answer is check the right side. So minus 2.1 uska right side mein kitna hai poles? 2. 2 is a even number. So minus 2.1 is not a root locus. So what is the rule? What is the rule? Rule is if you want to check any point on the real axis, whether it's on root locus or not, uska right side mein total number of pole and total number of zero should be a odd number. If total number of pole and zero is an odd number, that means that point is on root locus. Check any point here, minus 2, minus 3, minus 6, minus 7. Question is minus 7 point or minus 3 or minus 4 or minus 4.5? Is it on root locus? So is the root locus existing at minus 4? Answer is no. Why? Because minus 4 ka right side mein dekho, how many poles are there? 2 poles. 2 is an odd number. Hence, minus 4 will not be on root locus. So very important concept, very simple concept. झट से समझ जाता है. Initially थोड़ा हिचकिचाहट होती है, but later on you will understand easily. And whenever you are calculating this pole and zero, you have to consider the imaginary pole 0 always. Suppose there are two other poles at minus 1 plus j and minus 1 minus j, and complex conjugate poles always appear in conjugate. So if there were two poles here, this and this, okay, then if you are asking this point, suppose minus 1.j, so there are two more poles at suppose minus 0.5 and plus j and minus 0.5 minus j. In that case, I am asking whether minus 1.5 is on root locus, yes or no. So in that case, you have to say check to the right side. One real pole is there, minus 1. Another complex conjugate pole is there at minus 0.5 plus minus j. But so this 2 and 1 number is 3. That means this minus 1.5 will be on root locus. So whenever you are applying this step 3, in that case you have to consider all the real pole, complex pole, everything you have to consider. So in this numerical there is no complex pole, only real pole is there. So whether minus 1.5 or any point in between minus 1 point, minus 1 or minus 2, is it on root locus? Answer is yes, because any point between minus 1 and minus 2, you take any point till minus 1.99 from minus 1.01. Any point you take, the right side there is an odd number of pole and zero. That means minus 1.01 to minus 1.99. All points are part of root locus. That means you have to darken this part. That means what is the meaning? Meaning is minus 1 will come to some point, minus 2 will come to some point, and they will move off from the real axis. So this is the for this numerical, this is the real part of root locus. Then we are calculating that asymptotic angle. I told you that asymptotic angle will be 2. So how to calculate it? Number of poles p is equal to 2, number of 0 is equal to 0. In that case, one angle will be 90 degree, another will be 270 degree. इसके पीछे भी formula है. I will give you next day. But you remember for time being theta c calculation. So theta c calculation I will give you next day. So you remember that whenever number of poles are 2, there will be two asymptotes. One will be 90 degree, another will be 270 degree. So for all, whenever p minus z is equal to 2, remember this, whenever p minus z is equal to 2, there will be two root locus which are going to infinity. So one will be having asymptotic angle of 90 degree, another will be having asymptotic angle of 270. So don't check only pole. I'm making it a little difficult. Don't check only number of poles. So some people say number of pole is equal to number of root locus. No, p minus z is number of root locus. So in this case, if I give you that two zeros are there, in that case p minus z is equal to 0. In that case, this step 4, you will not have to do. because you have to say that p minus z is equal to 0. That means no root locus is going to infinity. So if p minus z becomes 1, p minus z becomes 2, p minus z becomes 3, then only step 4 is relevant. So when p minus z is greater than 0, okay, greater than 0 means it will be integer only. It can be 1, 2, 3, 4, 5 only. So pole minus 0 should be greater than 0. In that case, only this fourth step is having its relevance. So initially we are going to see only pole system. We are not going to see any 0, k by s plus 1, s plus 2. This is the first numerical. So p minus z is 2. There will be two asymptotes, 90 degree, 1 to 70 degree. If p minus z is 3, like the numerical I had shown you in printed form, s into s plus 3, s plus 6. So in that case, p minus z is 3. In that case, there are 3 root locus. What will be the asymptotic angle? We will calculate it from formula 60 degree, 180 degree, and 300 degree. So I will conclude this lecture with a very simple more calculation. What is the position of sigma c? Okay, so breakaway point calculation we will do tomorrow. Sigma c. What is sigma c? From which point you are going to draw the asymptotes. So asymptotic angle first we have found out 90 degree and 270 degree. But from which point? So what is the point on real? So sigma c point is always on real left hand side of S plane. So what is the point? So point is whatever the poles are given, whatever the poles are given. Some pole might be sometime at the right side also. So we can give you an unstable system also. Not necessarily all the pole will be always in the left hand side. So we can give you unstable root locus to draw. Don't mind that. So sigma c is equal to minus 1 minus 2 divided by 2. What is minus 1 and minus 2? If you check the poles, minus 1 is the real part of the first pole. Minus 2 is the real part of the second pole. Okay. So what is sigma c? How to find sigma c? Sigma c is the real part of all the pole do their summation minus real part of all the zeros do their summation divided by p minus z. So I'll tell you this formula. Sigma c is summation of real part of all the poles. So in this case there are two poles. One is at minus 1, one is at minus 2. So that's what I have done, minus 1, minus 2. So summation of all the real parts of poles minus, where is the minus of the formula, summation of real part of all the zeros. So in this case zeros are not there because you can find numerator is only k. Okay, so that's why summation of real part of the poles minus summation of real part all the zero divided by p minus z. So in this case there is no zero, there are two poles, so p minus z is equal to 2 minus 0, that is equal to 2. So we are finding that minus 1 minus 2 divided by 2 means minus 1.5. That means in the root locus we will start at this point. I have written here sigma c is equal to minus 1.5, which is exactly between minus 1 and minus 2. So don't average. Okay, so it is not average. It is real part of first pole plus real part of second pole minus all the zero real part, summation of that divided by p minus z. So in this case it is minus 1 minus 2 minus 0 because zeros are not there divided by 2. So you have to draw one line, dashed line here. Starting from minus 1 you have to draw 90 degree. Starting from minus 1.5, sorry, it's not starting from minus 1, starting from minus 1.5 you have to draw 90 degree. Starting from minus 1.5 you have to draw 270 degree or minus 90 degree. How to draw 270? Always go anti-clockwise from the positive side of x-axis. So this is positive side of x-axis. From there always you have to draw this way. Okay, so in this case you are finding that this is starting from here, you have to go like this. Okay, that means this is 270 degree or minus 90 degree. Minus 90 तुम इधर से भी draw कर सकते हो. Okay, starting from here you have to go minus 90. So one will be drawn like up, another will be drawn like down. That means one root locus will come from minus 1, come to this point, breakaway point, whatever is the breakaway point, and will go upward. This is one root locus. Another will be 270, sorry, it will start from minus 2, come at this breakaway point, and it will follow to the downward direction, minus 90 or 270 degree. So these are the two root locus which are guided by two asymptotes, which is 90 degree and 270, and they will go towards infinity. So how many, if there are only two poles, how many root locus are there? So answer is 0 is not there. There are only two poles, so p minus z is equal to 2 minus 0 is equal to 2. So there will be two root locus. One will start from minus 1, another will start from minus 2, and they will come and meet at one point, and then one root locus will follow the plus 90 degree line. Another root locus will follow the minus 90-degree line or plus 270-degree line, and they are going to meet two zeros which are kept at infinity, plus infinity and minus infinity. So this is the root locus. So from traditional method you can do this numerical, or by root locus method I have only shown you the first 4 steps or 5 steps. So which 5 steps I have shown you today? We will start from the 6th step onwards. So first I have shown you the step 1, write down what are the poles and zeros, and from there find what is p minus z. Second, and from p minus z you will be finding how many locus will be there which will go to infinity. Second case, a root locus, a real axis root locus. How to find it? Take any point and just check its right side. If you are finding that in right side total number of pole plus 0 is odd, that means that point is lying on root locus. Third step, draw this real axis. So this is the third step, is just drawing the real axis root locus. Fourth step, find what are the asymptotic angles. So if you are finding there are 3 real roots, asymptotic angle will be 60-degree, 180-degree and 300-degree. If there are 2 real roots, that means there are two root locus which are going to infinity, asymptotic angle will be 90-degree and 270-degree. And the point from where we are drawing the asymptotic angle is called a centroid. Sigma c formula is summation of all the real parts of poles minus summation of all the real part of 0. सिर्फ real part लेना है, imaginary part नहीं लेना है. Okay, so sigma c centroid formula, summation of all the real part of poles minus summation of all the real part of 0 divided by p minus z. In this case p minus z is 2, that's why sigma c is minus 1 minus 2 divided by 2, that is minus 1.5. We will start with calculation of breakaway point tomorrow. Thank you.